Good afternoon to everyone. My name is VAMSHI. I'm pursuing my BTech third year at KL University. Today I'm making a video blog on gradient descent algorithm. So today we are going to learn about what is gradient descent algorithm and where it is used and why it is used. So let's get quickly into this video. So what is gradient descent? As we know that gradient descent is an iterative first order optimization algorithm and it is used to find local minima of the given function. As we know that this gradient descent is a very popular optimizer. This method is widely used in the machine learning algorithms and deep learning algorithm to minimize the cost functions. Example, we can take the linear regression. So due to this importance and the ease of the implementation of this algorithm, it is usually taught at the beginning almost in all machine learning courses. As we go through any machine learning course, this gradient descent algorithms is more popular. So while we talking about minimization cost, first let us know about what is cost function. It is a function that measures the performance of a model for any given data. If we are given with a data, it measures the performance of a model, means the training model which you are training, it measures its performance. And cost function quantifies the error between the predicted values and the expected values present in the form of a single real number. After taking hypothesis with this initial parameter, we calculate the cost function. And what is our main goal is to reduce the cost function by modifying the parameters. And this modification is done by using this gradient descent algorithm over the data. If we are given with any data, we generally use this gradient descent algorithm in order to find local minima, means in order to find the minimum cost function. So moving to next slide. So it is a pictorial representation, means diagrammatical representation of, here you can see the cost versus weight. As weight, it is a slope between the cost and weight. As here you can see the gradient, it is an initial weight and it is an incremental step. Starting from this point, the gradient is always start incrementing from this. At last here we will get the minimization cost. It is known as local minima. It is the derivative of the cost. It is an incremental step. So this is what the minimum cost is done by the gradient descent algorithm, and it is one of the most popular optimization, and it is widely used in many kind of algorithms in machine learning and deep learning. So moving to next slide. As we discussed in the previous slide, what is local minima? As I mentioned in the previous slide, the minimum cost, the local minima, this cost function may consisting of many minimum points. As in the previous slide I have given a pictorial representation of the gradient. As if the incremental step is coming down, the cost function may consisting of many minimum points. So the gradient may settle on any one of the minima, which depends on the initial points and initial parameters and the learning rate. Therefore, this optimization may converge into two different points with different starting points and the learning rate. So this is known as what is local minima, as I explained in the previous slide with the picture, with the diagrammatical representation. And here you can clearly observe how it is works and how this cost function make up what this cost function consisted. So moving to next slide. There are three types of gradient descent algorithms are there. In gradient descent, it has divided into three components. One is batch gradient descent, stochastic gradient descent, and mini batch gradient descent. So moving to first thing, batch gradient descent. So it is a type of gradient which processes all training example for each iteration of the gradient descent. But what is the drawback in this batch gradient descent is it has training examples are large. So as training examples are large, it becomes more computational to work with this. As it has more training examples, it becomes more computational and it becomes more very expensive. So if the training examples are large, hence the gradient descent is not performed. As it becomes more computational, it's difficult to work with this batch gradient descent. Instead of using this batch gradient descent, there are other two optimizers, means there are another two different kind of gradient descents are there. They are stochastic gradient or mini batch gradient. So we'll learn about that also in upcoming slide. Stochastic gradient descent. So it is a type of gradient descent which processes one training example for per iteration. So for every single iteration, this gradient descent processes. Hence, these parameters are being updated for each iteration in which only a single example has been processed. Hence, as we discuss the batch gradient descent, it becomes more computational. Here, hence it is quite faster than the batch gradient descent. So again, if we use large training example, even the stochastic gradient processes by a single example, which can be additional and overhead for systems as number of iterations will be quite large. So moving to next slide. Mini batch gradient. It, it is a type of gradient descent which works faster than the both gradient descent and stochastic gradient descent. Example, here we can see that here B examples were there where B is less than M processed per iteration. So even if the number of training examples are large, it is processed in batches of B training example in one ago. Thus, it works for larger training example with lesser number of iterations. So, thank you so much for listening this video.